Hi everyone, welcome back to Intellipaat's YouTube channel. Today is the day 5 of AWS series. In today's session, we will be learning about AWS Load Balancer.
So before moving on with the session, please subscribe to our channel.
And also hit the bell icon for the upcoming updates from our channel. And also, if you enjoy our content, you can leave a like.
So let's start with why autoscaling. Now, what would you do if your website's traffic increased and it needs more servers? So let's say you have a website, but your website is getting popular day by day. So you need more servers. So you already have an on-premise setup in your particular garage or wherever your website is running on. So you have that, but every time your website's traffic is increasing, you need more servers. So what you can do for that? So now let's discuss about that. So this will explain us why do we need autoscaling. So now I need one more server for my website. So let's say your website is getting popular day by day. Now you think you need one more server to accommodate the traffic. So you get one server and you configure it manually. Then your traffic is increasing day by day. So now you need a lot of servers. So now you're thinking for a much simpler solution where you will just have to concentrate on your application instead of your servers. So you don't want to go into the IT part of your application, you just want to concentrate on the code of your application. So now so many servers, you'll have to spend so much time configuring them. So you might not have enough time to make your application better. So now if it's an on-premise setup, you will have to do everything manually and it will be very hard if you want to scale down. For example, you bought 10 servers for 1000 users. So each server can accommodate 100 users at a time. So let's say one day your traffic goes down to 200 instead of 1000. So now 8 servers will be sitting there idly, still costing you money, but it is not gaining you any money because 2 servers is more than enough to accommodate 200 people, but you have 10 different servers. So now how to solve this? So then AWS came up with an idea to automate the scaling process dynamically. That is, whenever the traffic increases, you'll get more servers. Whenever it decreases, you'll get lesser servers. So how does that work? So let's discuss what is autoscaling, because if I explain it theoretically, you might get the grasp of it, but when I show you the demo, you can understand what exactly is autoscaling. Okay, now let's get started. So now this is why we need autoscaling, because we cannot buy servers and configure them manually by ourselves, and it is very hard to downscale them because they are manual servers sitting there and we cannot just take them and go sell them because we don't need. That will cost you a lot of money. So instead you can use AWS, but how to use that? So now assume that your application normally requires one server for 3 users. So this I was explaining it to you with 100 users. So let me make it simpler with this slides. Okay, now assume that your application normally requires one server for 3 users. So you have a server which is, so you can see this is your web application. You need one server to accommodate this application. Okay, now your web application's traffic going up, your website is suddenly experiencing a lot of traffic one day and one server cannot handle all the requests. So now what do? You bring in auto scaling in between your servers and your users. So now what auto scaling does is, so let's say there are 3 users. So for 3 users, one server, so this server is more than enough. But when you get 3 more and 3 more users, now you will need to have one more and one more server, because each server can accommodate 3 users. There are 9 users currently, and auto scaling will do the job. Whenever there is an increase in the traffic, it will give you more servers. So let's say if there are 6 users, now it will give you only 2 servers, because it will automatically reduce the one server which was available. So before you had 3 servers running for 9 users, now you have 2 servers running for 6 users. This will also decrease your cost of operation, because you only pay for this 2 servers right now. You do not pay for the third server. But if it is a manually set up on-premise server, then you'll have to pay for that as well, because that is using electricity as well. So now this is how auto scaling works. So now let us see what is auto scaling. So AWS auto scaling is a web service. So this monitors your applications hosted on your on-premise server or even the AWS server. Mostly it is used with the AWS server. Okay, now it monitors your applications hosted on the AWS server and adjusts the capacity according to the traffic for providing steady performance and high availability. This basically means this auto scaling service will monitor the application or the server's running capacity. That is, let's say you have two servers, and whenever the CPU utilization of the servers go above 80%, you need one more server. So if you want to do that, then you can go ahead with auto scaling. Also, let's say you want one lesser server, that is, you have three servers and you want to remove one server. Whenever the CPU utilization average goes below 20%, you want to remove one server, then you can again go ahead with auto scaling. So this is what auto scaling is. So there are two types of scaling. One is vertical scaling and one is horizontal scaling. So in AWS, auto scaling is only available for horizontal scaling. Vertical scaling you can do in AWS, but it is manual. So let's say you have a small instance with 10 GB of RAM. So now if you want to scale it up, then you can increase the RAM to 30 or 50 GB. So if you increase the same instances RAM to 30 or 40 or 50 GB, then that is called vertical scaling, because you're not provisioning more resources, you're using the same resource but increasing the capacity of it. So now coming to horizontal scaling, again you have one server with 10 GB. So now you want more, so you just launch another instance with 10 GB and host your application there as well. So again, whenever the traffic increases again, then again you will launch or you will create one more server with another 10 GB. So now it is equally distributed across three different servers. So horizontal scaling is mostly used in AWS. Vertical scaling is not done automatically. So these are the types of scalings. You can look into this more. Now moving ahead, we've looked at auto scaling. So auto scaling is a service to increase the number of services. So let's say you have 10 servers right now, but how will the system or how will AWS know which server to send the user to? So let's say you have 10 servers. Now there are 1000 users. So let's say the first server is getting 500 users, second server is getting 200 users, third and fourth and fifth servers are getting 100 users. But the last 5 servers, even though they are running the application, even though they can handle the requests, they are again empty without any traffic, because there is no medium to balance this load across. So for that we need elastic load balancer. So now if you use elastic load balancer, you can basically redirect your users to particular domains. In Intellipaat there is Intellipaat.com as well as Intellipaat.com/blog. So these two are hosted in different servers. So whenever you go to Intellipaat.com, you are in a different server. If you go to /blog, you are in a different server. So now to balance that load, that is, whenever you type Intellipaat.com, you will be taken to a different server, and whenever you type Intellipaat.com/blog, you will be taken to a different server. So that both have the same domain name, but using ELB, using a load balancer, you can do that redirection. You can basically, whenever a user comes in, so if he types that particular address, he'll be taken to one particular server that will be handled by the load balancers. Now let us look why load balancers. I've explained it to you, but still we'll look at so that you understand it even clearer. So assume your application runs on multiple EC2 instances. How do you know that the traffic is distributed evenly among these instances? So this is the question I asked you. So let's say you have multiple EC2 instances, but still you will not know whether the 1000 users are segregated and sent to every single EC2 instance. Some instances might be idle as well. So that's why we need elastic load balancing. Now again, there are 300 users. What if there are 300 users and still running on one instance, but you have 3 different instances right now? So you have 3 instances. Even though you have 3 instances, all the 300 users are redirected to one particular server. So this is not acceptable, right? Because you are paying for the other 2 servers as well. So to do that, we bring in elastic load balancing. So ELB basically receives all the user requests. So let's say you have 100 different servers. So you will not be directly taken to that particular server from your request. First you will be taken to ELB. So now ELB is the single point of entry. So now ELB decides which server it should take you to. So let's say there's a first person comes in, it takes you to the, so let's say this person comes in, it takes him to the first server. Then this person comes in, it takes him to the second server. Then this person comes in, it takes him to the third server or her to the third server. So right now you can see the traffic is being evenly distributed. It's not the case it will be only evenly distributed. There is also another way of distributing, that is application load balancer. So in that case, what you will be doing is, so the first instance will have a different application, second instance will have a different application, whichever application the user is requesting for. So ELB will redirect that user to that particular server. So even that can be done. Okay, now this is exactly why we need elastic load balancing. Even though you do auto scaling by increasing the number of servers or decreasing it, you need a single point of entry which decides which server to send the user to. Now, so in the simplest terms, elastic load balancers accepts the incoming traffic from its clients. So the clients can be a mobile, a iPad or a Samsung pad, a tablet, a laptop, a desktop. It can be any device which is connected to the internet. Every single request goes to the elastic load balancer. Now the elastic load balancer routes these requests to the targets which the client wants. So basically, I might want to go to intellipaat.com, but another user might want to go to intellipaat.com/blog. So both of these requests come to elastic load balancer, but load balancer will decide path should it send that particular user. So the intellipaat.com user will be sent to the first instance or the first server, because that application is hosted in the first server, and in the second server there might be /blog website is hosted, so the second user might be taken over there. So this is why we need ELB. And what is ELB? So in AWS there are three main types of ELB. There is classic load balancer, there is application load balancer, and network load balancer. So first, coming to classic load balancer, this is basically the most simplest form of load balancer. It doesn't have any criteria. It uses a round robin method. So whenever you refresh it or whenever a new user tries to come in, it takes him to a different user. There is no particular agenda here. You to any server you want. It does not distribute it evenly, but it is a good way of distributing as well. Now coming to application load balancer, as I said, you will have two different applications, maybe in the same server or two different servers. Now you can set up the load balancer so that whenever one particular application is chosen, it will take you to that particular location. If another application is chosen, it will take you to another location. Network load balancer is another type of load balancer which is used to balance the load when a particular port number is taken. So let's say you want to access port number 80 and you're typing that in the website. So let's say www.intellipaat.com :80. So it might take you to one particular server, and :8080 it might take you to another server because they are different. Okay, now we've looked at the three different types of load balancers as well. Now let us see a demo. So this demo, first we'll look at auto scaling, and after looking at auto scaling we're going to look at an ELB demo. So let's get started. So I already have two different servers running, and each server has a different website. So let's check what is the website running in the first server. So it is showing that this is server 1, then second server showing as this is server 2. So to differentiate between these two servers, I have two different websites, server 1 and server 2. Okay, so right now why do I need this? So because I'll have to show a difference between so while doing the ELB demo, I'll have to show a difference, right? Whether it is taking you to a different server every time or a different server whenever you need to take you to a different server. So that we'll have to see. So first I have two servers. Okay, next I have two AMIs of those two servers. So this is server 1 and this is server 2. So server 1 and server 2. Now coming down to AMIs. Okay, now there is server 1 image and server 2 image. So if I launch a EC2 instance using this AMI, then I will get a server which has the same web page in it. And if I use server 2 image, it will give me a website with this same AMI in it. Okay, so this is how it works. So right now let's start off with the auto scaling demo. So once auto scaling demo is done, we'll move ahead to a ELB demo. Okay, so first we'll have to go to auto scaling groups.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Okay, so first let's create an autoscaling group. To create an autoscaling group, you need a launch configuration. A launch configuration is basically an AMI. So an autoscaling group should understand which type of an instance that it should launch every time when a particular condition is satisfied. So let's say CPU utilization goes above 80%. So if that is satisfied, one server should be increased. But what type of a server should that be? So I want that server to be server 1. So I'm going to use, so you can see launch configurations over here. These are my older ones. So I'm going to create a launch configuration, create a new launch configuration. I already have an AMI, so server 1 image, and then I'm going to choose the same thing. I'm going to give this launch configuration a name, server 1 launch. Done. Next I'm adding storage, same storage, and I need a HTTP rule. So this is because I have a website and that website is hosted in this port number. Now I'm clicking review and create launch configuration. So if you already have a key pair, just choose that key pair and create the launch configuration. I already have one, so I'm not going to go ahead and create one. So it's done. So now it prompts us to create autoscaling group page. So we have created the launch configuration. A new instance, whenever it is launched, it should have this is server 1 website. So right now I'm going to create a autoscaling group. So this is going to be called server 1 auto, and it should start with one instance. So I'm going to choose 3 different subnets. So my instances can be launched in 1F, 1B, 1D. Other than that, it won't launch. If you want your instances to be launched in all of the availability zones, then just select every single one of them. Okay, so right now this is what I'm providing. Then do we need to provide any advanced settings? Okay, so health check grace seconds. So I'm going to reduce this to 60 seconds. I'm not going to waste a lot of time over there. Receive traffic from one or more load balancers. I don't need that. Okay, so now we are creating an auto scaling group. Okay, done. So now use scaling policies to adjust the capacity of this group. Okay, now I can have one instance, and if the scaling policy goes above, the maximum I can have is 2 instances. So the thing is, my website needs one instance as a minimum, and at the maximum it needs 2 instances. So let's say your website is a huge website, so at minimum you can have 1, and at a maximum you can have 10, or at minimum you can have 5 and maximum you can have 10. So that's your wish. So I'm going to go with 1 and 2. So I don't need more instances for this demo right now. So you can see here scale group size. This is the name of this particular condition. So average CPU utilization, the target value is going to be let's keep it 70, and I'm going to give 60 seconds. So it will take 60 seconds to warm up after scaling. Okay, that is fine. So I'm adding this, and you can see here average CPU utilization, and whenever the CPU utilization goes above 70, it will automatically create a new instance for me. And so the thing is, whenever it is below 70, I think it will automatically decrease one server, or you can also set up that. So here you can see you can create alarms. So this is to increase group size, this is to decrease group size. So let's create here. So see, read capacity units, write capacity units, I don't need that. So increase group size, I'm going to create one. I don't need to send any notification. So average CPU utilization, if it is greater than 70% for at least 1 minute, at least one consecutive period of 5 minutes, then it will create an alarm for me. So you can see here, so this is to increase and this is to decrease. So whenever this alarm is going to be triggered, it will increase one instance. Whenever this alarm is going to be whenever this particular alarm, which is decrease group size, this is going to be triggered, it will reduce one instance. But I'm not going to do that. So I'm going to use the normal scaling policy itself, because this is much easier to understand at first instead of going into the depth of it. First, whenever the average CPU utilization is above 70, it will increase, and when it is not, it will decrease. So that's it. It is that simple. Configure notifications. I don't need a notification. I don't need a tag, and I'm going to create this auto scaling group. Done. So auto scaling group is created, but at first one instance will be created inside your auto scaling group. So if I come down, you can see server launch one. If I go to activity history, and if you come down, not yet in service, launching an EC2 instance. So let me open the instances page in another tab. And here we already have two instances. There should be a third instance which is being created, and you can see it is also running. So I'm going to name this as auto server 1. Done. So now let us check whether this instance, so I have the image of it. I created the launch configuration, created the auto scaling group, but this particular server does not have anything else. That is, I did not go inside, I did not launch a web server, I did not put any website. But if I paste this and hit enter, it should have the server 1 page. So let me hit enter, and it is showing that this is server 1 and this is also server 1. So basically I've created an auto scaling group for this particular AMI, and right now if the CPU utilization goes beyond 70%, then it will launch one more instance. So to do that, I have a sample piece of code, and we're going to use that inside the instance. So first I'll open the instance, and it's the same key pair which is over here, and open. Yeah, so it is open. Now let us check whether Python is installed. Sorry, I think Python 3 might be there. Yes, Python 3 is there. Okay, done. So now what I'm going to do is, so I have a Python script to increase the CPU utilization over here in this notepad. So I'm going to copy this and paste it inside a file which I'm going to create right now. So I'm going to create a file called nano cpuutil.py, and let me just make it bigger and paste it here, save it. Okay, done. So now what I'm going to do is I'm going to run this file, and it's running over here. You can see that. Okay guys, so now the next logical thing we'll have to do is we'll have to sit and wait until a new instance is being created. So until then we're going to monitor this instance. So monitor in the sense we are going to check the CPU utilization. So let's check the current CPU utilization. So okay, let's check for 15 minutes, 1 hour. You can change that over here. Currently it is not even showing because the CPU util is very low. So let's wait until it goes above 70. So 70 is over here. So 70 is in between here. So we'll have to wait until the CPU utilization increases. So this is going to take a time of 5 minutes. So within that, what we are going to do is I'm going to create few let's just begin with ELB, and let's come back and check over here. You can see it's still running. So once this increases to 70%, then there will be a new instance running over here. So until then, let us go ahead with auto scaling. So coming down, you can see here load balancers. I'm going to open this. So for load balancers, guys, what we're going to do, we'll need another auto scaling group. Basically that is going to be server 2. So let this continue, and let's create one more auto scaling group for our load balancer. Okay, so create auto scaling group, create the launch configuration, my AMIs, server 2. So this is all going to be the same steps. So I'm going to speed up here. So this is going to be server 2 launch. Next I need SSH rule. I need SSH and HTTP, and review. and done, and create launch configuration. Choose your key pair. So I've created another launch configuration, and now using that launch configuration I'm going to create another auto scaling group, which is going to be server 2 auto. Again, I'm going to choose 3 subnets. Next, so I'm not going to configure any scaling policies because I've already showed that to you how to do that. And done. I've created another auto scaling group. I'll explain to you why do we need 2 auto scaling groups for our load balancer. So our load balancer will get request from this auto scaling group and also this auto scaling group. Okay, now coming here, if I refresh, there should be another instance getting created, and you can see that over here in US East 1F. Let's check its CPU utilization first of all, and you can see it is around 53. So this CPU util should increase above 70, only then we'll know whether it is working or not, our auto scaling group. So this, let's check which instance this is. And this is server 2. So as I was telling, I created another auto scaling group. So that created another server for me, which is named as server 2. So that is also created, guys. So now we have 2 auto scaling groups with 2 different servers. So our first server, currently the CPU utilization is getting increased and it is at 53.9 right now, and once it goes above 70 we'll get a new instance. So for that we'll have to wait. So I'm still waiting. It's still at 53.9 and it will be gradually increasing. So we'll only see that when the CPU util goes up. Let's wait for that. So let's also check whether a new instance is getting created or not. So until now there is no instance getting created, so obviously it is still under 70, and now you can see there is a steep increase to 99, from 53 to 99. So right now let's check whether a new instance is getting created, because a new instance will obviously get created, but let's wait and see. Because so right now it will wait for 1 minute whether it is above 70 or not. So if it is above 70 for a continuous minute, then it will give us a new instance, and now you can see a new instance getting created, and I'm going to name this auto server 1 and 1.1. And once it's running, let's check whether it has server 1 inside it. If it is server 1, then we have done it correctly, we have done auto scaling correctly, and we have created another instance for us. We did not scale it, guys, it automatically scaled, and now you can see this is server 1 and even this is server 1. So we've created an instance without creating an instance. That is, we've set up a particular condition. When that condition got satisfied, another instance got created. Simple as that. So let me just stop this. We've done our auto scaling demo. Close this instance. Done. Okay, so now we have one auto scaling group which has 2 instances, another auto scaling group which has 1 instance. Okay, now we have done the auto scaling demo. Now we'll have to start off with the load balancer demo. So let's get right into it. Okay, so before going on to this, I'll have to do one more small edit in server number 2. So we open this and make that edit for you, because we'll have to show a different so we'll have to set up different path for auto scaling group 1 and 2. So let's say if you are typing in intellipaat.com, you will be taken to server 1, and intellipaat.com/blog you will be taken to auto server 2. So that's what we are going to do right now. So for that we'll need to set up a different path inside auto server 2. So for that I'm going to open it and going to create another folder over there, and also create another simple website inside that. Okay, so as I'm using Apache 2, so all my website is over here. So if I do an ls, you can see index.html. So this is where the file is. So I don't want this file to be shown whenever. So I'm going to make var, I'm going to create a blog folder. So whenever
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
we are going to create a load balancer, that load balancer will have a DNS name. So when we use that DNS name in our browser, it should take us to the first server, and when we use /blog to that DNS name, it should take us to this particular server. So we are going to do that. I'm going to create a file here, index.html, and this is the server to blog site. So I'm going to save this and done. And now we are set to go with load balancers. Before that, let's just check it once. So now it's showing this. Now if I do a /blog, and it's showing this is the server to blog site. So this is what we're going to do. And first of all, let me just close it. These are just extra. And okay, so I'll just close this as well. Now I have servers, and let's get started with load balancer. I'm going to click on create load balancer. Go to application load balancer, and I've already explained it to you. It will take me to one particular URL first time and second URL whenever I type it in, because I'm going to set it up like that. So I'm going to give it a name as ELB live 1. It's going to be internet facing, not internal, and it's going to listen to port number 80, and I'm going to choose default VPC. And so now what you can do is, if you know in which availability zone your instances, you can choose those instances. If not, if you do not know, because you're going to be using auto scaling and it can launch your instance in any of these availability zones, you can just click on every single subnet and just click on next. And it's not listening to a safe listener because it is listening to HTTP, not HTTPS, but that's fine. Now select an existing security group. I'm going to select this group. Next, configure routing. So first you'll have to understand we have to create two things. So we have to create two target groups. So whenever we are going to type in just the DNS name, let's consider the DNS name is intellipaat.com. It will take us to one auto-scaling group, that is the first auto-scaling group. Whenever we type intellipaat.com/blog, it will take us to the blog site of the second server. That is what we are going to do. And for that, we need two target groups. So first target group is targeting the first auto-scaling group. Second target group is targeting the second auto-scaling group. And I'm going to give the first target group a name. This is going to be server 1 target. It's going to be an instance, HTTP 80, and everything else is the same. So here the path is / because it is going to take the index.html file directly from var/www/html. Inside that folder, there is an index.html page. That is what is going to show when you type the DNS name. So done. Next, register targets. So I'm not going to register any target right now because I'm going to connect the target group to the auto scaling group. So I'm not going to register any target. You'll just have to remember this and create. So we've created a load balancer, and you can see it also has provided a DNS name over here. So once this DNS server is running properly, we will be able to check out. So before that, so let this be running. Now let's set up the other parts of this particular demo. So we have an ELB which is connected to a target group, but that target group is not connected to any auto scaling group. So to connect that, we'll have to go to auto scaling groups, and server 1 auto is going to be connected to server 1 target. And I'll just close this, actions, edit, and coming down we can see target groups over here. If I click here, it will show me the target group which I already have. So here you can see there is a server 1 target. I'm going to choose it and hit save. So now I've created one part of this particular load balancer. So let's check that. So it's still provisioning. You see here. So what we're going to do is, if I do this, it will show this is server 1, and if I do this, it will show this is the server to blog page. So this will work only when this particular ALB is in available state, that is active state. So we'll have to wait for that. So within that we'll finish the target group work. Okay, now we have connected the load balancer to a target group which is connected to an auto scaling group. So we've done it for one auto scaling group. Now we'll have to do it for the second auto scaling group as well. Now let's create another target group and attach it to the auto scaling group. Also attach that target group to the load balancer. So create target group. Target group name is going to be server to target, and here the path is going to be blocked. So this is the target and create. So I don't think this should be changed. I'm just going to keep it slash. I'll show you where to do that change. So now we have another target group done. So now go to auto scaling group, go to the auto scaling group which you will have to attach this target group to, click edit, go down and target groups, server to target, hit save, done. So guys, now we have two target groups attached to each one of these servers. So to server to auto scaling group, we have target group which is server to target, and server 1 auto we have server 1 target. So server 1 target is already connected to the ALB. Server 2 target is not connected. Now we'll have to do that. I'll show you how to do that. So let's go to load balancers. Let me check whether it is active or not. So it is active. So let's just refresh this once. So it's still loading. So let's just finish off the remaining work and let's check that again. Now going to listeners. So you can see here, okay, it does not allow traffic. So one mistake we've done is the security group of this particular load balancer is not allowing. So what I'm going to do is, sorry, not this. What security group did we attach? So I'm going to go to that security group and change it. So I'm going to go to the security group, go to inbound rules, and so it is allowing only SSH. I don't need SSH actually, I just need HTTP, and it's going to be anywhere, and I'm going to delete this. So done. So now, yeah, so now I've changed it. Now our load balancer will have access to port number 80. And let's go to listeners, and now you can see, yes, it can listen from port number 80. Let's refresh this again, and now you can see this is server 1 page. So we have successfully connected the load balancer to the target group which is targeting the auto scaling group number 1. Okay, that is done. So now let us see whether the blog page is working. The blog page will not work because we have not attached that target group with the load balancer. Now let me show you how to do that. So go to add listener and port number 80. So the thing is, you'll have to add an action. Coming down, sorry, another mistake. So you'll not have to click add listener, you'll have to actually go to view and edit rules because you already have a listener for port number 80. So now you'll have to click on plus, click on insert rule. Add condition is basically path, and the path is /blog. Okay, so whenever the path /blog is typed, it is going to forward you to the target group server to target, and that's done. So click here, hit save, and a new rule has been created, guys. So let me just brief it once again before checking out whether the demo is working or not. So we have created a load balancer which is connected to two different target groups. Each target group is connected to a separate auto scaling group. That is, whenever this particular DNS name is typed, it will take you to the first auto scaling group, which is the first server. And whenever /blog is typed, it will not take you to the first auto scaling group. It will take you to the second auto scaling group because we have connected it with target number 2. So I'm going to hit, and it's still showing And again, I did another mistake. This is a simple mistake actually. Let me just get in and edit this and click here, and I'm going to edit this to this and done. Update. So one slash, let me try this again, and it's still not working. So server Apache 2 server at port number 80, it's not able to find this particular server, and yes, now it's finding it. And this is the server 2 blog site, and this is the server 1. Whenever you are typing a particular DNS name, it's taking you to a different server. So this is how application load balancers work. You can set up your path accordingly. So now any user who is just checking the home page doesn't need to go to the blog page. So the server is dividing the traffic between two auto-scaling groups. One auto-scaling group is having the home page, and another auto-scaling group is having the blog page. So now maybe there are thousand people, 1,000 persons are reading a blog in the Intellipaat sites, and 1,000 people are visiting the course page. So now the course page traffic and the blog site traffic is divided, so that now these servers can handle both the traffics equally and equally well. So guys, this is how you create an auto-scaling group and also a load balancer, and then also combine them to work properly. So I think if you understood a lot in this particular session, you've learned how to create an auto-scaling group, a target group, you learned how to create a load balancer, and also how to combine all of them together to make it work. Okay guys, we've completed the demo.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below.
Okay guys, we've come to the end of this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below.
Thanks for watching.